Hello students, in this lecture we'll find the coordinates of center of curvature at any point of the curve y is equal to fx, and also drive an equation how to find the circle of curvature at any point to the curve y is equal to fx, and also find the equations of the chord of curvature at any point parallel to x-axis and y-axis. So let's first try find the coordinates of the center of first find the coordinate at any point P to the curve y equal to x. Let AB, this AB is the curve of this y equal to x, and P is any point whose coordinate is xy on this curve. Let the coordinates of center of curvature at any point P be x bar and y bar, C with coordinates x bar, y bar, which lies on the normal, at point P at the distance rho from P, where rho is the radius of curvature, which you have derived in the previous lecture. Let the tangent at P makes angle psi with the positive direction of the x-axis. Therefore, the normal will make the angle psi, because normal is perpendicular to this. Normal is perpendicular to the tangent at the point P. So the normal will make angle. Now this is psi. This is pi by 2. So actual angle is sum of the two inclined angle. So therefore the normal will make angle pi by 2 plus psi with the position of x-axis. X-axis. Uh, Now the equation for normal at point P. Let us suppose that any any point, any point, any current point on the normal is whose coordinates are capital X and capital Y, and which is at a distance r from P. R from P. Therefore, the slope of the we can write the equation for the normal by equating the slope. Slope of the P at the current point is Q. Let's put this current point is Q. This current point Q. 2 point, whose coordinates are capital X one, and R is the distance between them. So the slope of the line will be y, uh, small y capital. We can write small y minus capital Y upon small x minus capital X is equal to tangent of pi by 2 plus psi. So from if you simplify this, or we can write capital X minus small x upon uh, capital Y minus small y is equal to tangent of pi by 2 plus psi. So from this if we interchange them, we can obtain this equation. The two slopes of the normal. I'm not a simplification. We got x minus x bar upon cos of pi by 2 minus this is second coordinate minus sine psi, and sine of pi by 2 minus sine, this is cos of psi. And let the which are the distance between the point, current point x from the variant. Now the second point, therefore, the coordinates of any point on the normal will find x and y from these equations in terms of r. So this is equal to x is equal to x, capital X is equal to x, the second current point on the small x plus r minus r sine psi, and y is equal to capital Y plus r sine psi, the current point on the normal. Now, if r become rho, if r become rho, if this r become rho, then this capital X and Y coincide with small x bar and y bar. So if you take r is equal to rho, then they are the coordinates of the center of curvature. X bar is equal to x plus rho sin x minus rho sin psi, y bar is equal to y plus rho sin psi. Now Now we want to find the how to find the coordinates. We know that rho. We know the formula for rho is equal to 1 plus y1 upon y1 square whole square 2 upon 5. And the tangent of psi, and psi is equal to definition of y square. So if we take this P and the O point, and if it so, this is tangent psi is equal to perpendicular base. If we suppose this is equal to perpendicular and base is 1, this comes out to be 1 plus y square. So now substituting the value, if this is 1, then we can write sin psi is equal to perpendicular upon hypotenuse, and cos psi is equal to 1 upon this 1 plus y1 whole square. Now substitute the value of rho and sin psi and cos psi. We got x bar is equal to x minus 1 plus y1 whole square with respect to y2 upon y2, and this is equal to, what was this? This is sine of psi. Minus sin psi is equal to y1 upon root of 1 plus y1 square whole square 1 by 2. So x, after simplification, we got x1 is equal to, with denominator half goes, this is equal to x minus y1 into y1 plus 1 plus y1 whole square upon y2. Similarly, y bar, y coordinate of the center of which will be y bar is y plus 1 plus y1 rho, value of rho 1 plus y1 whole square is equal to upon y2, and the cos of psi is equal to 1 upon rho and root of 1 plus y. If we take the denominator, we got y plus 1 plus y1 square upon 1. So these are the center curvatures. Now, if we know the center curvature will be center curvature of at any point. They are related to the point, because from point to point, the center and the circle of curvature or the center of curvature varies. So we have to include the point at which we want to find the of the curve. This the center of curvature of any at any point on this curve y is equal to fx is x bar y is equal to this value. That is x equal to x minus y1 into 1 plus y square upon y2 and y plus 1 plus y1 square upon y. Now, if we know the center of curvature, then we can write the equation, because we know the radius is equal to rho. So therefore, the equation circle is equal to x minus x bar whole square plus y minus whole square. Now, what is evolute? The locus of the center of curvature of a curve is called evolute. I told you the center of, if you find the center of curvature at different points, center of this point, this every point. So we got a curve for this xy. So this is the curve. If we find the radius of center of curvature at each point, we got different value for of the center of curvature. The collection of the center of curvature is called evolute. It's a curve. The evolute and involute is called. It's evolute and involute. What is evolute? Evolute is this, and what is involute? Involute is the curve which evolutes, whose evolute we know is called evolute. So the curve y, the curve of the function y equal to fx is called involute, and the collection of the center of curvature at each point of the curve is called evolute. Involute and evolute. Now we'll find the length of the chord parallel to the x-axis as y-axis, right? Now again, this is AB the curve, this AB the curve, AB, and P is any point on the curve, P is any point on the curve, draw tangent at this point, which makes angle psi with the position x3. Now, uh, draw a circle, draw a circle with the circle with center C, rather circle, draw a circle, center of, let's see with the center of the creature of the circle corresponding point P with coordinate xy. Now draw the circle, and now draw a, we know that the center of the circle curvature lies on the normal. Normal, this line is PS is the diameter of the circle. PS will be perpendicular to the tangent. So if this is psi, this line. Now we want to find PQ, and these are chords. Chord of curvature is the chord passing to the passing any chord passing through the point P is called chord of curvature of H. How many chords we can pass through this? Infinite of five. So We want to find the chord parallel to x-axis as well as y-axis. So now let's draw PQ parallel to x-axis and PR parallel to y-axis and complete this paragon. Now this is equal to rho, this is 2 rho, PS is 2 rho. Now these lines are parallel, so this is side. Now this is angle, this is normal, center curvature or like normal, and CP is rho. So this will equal to this is total is 90, and this will equal to 5 by 2 minus 90. Now this again, because they are perpendicular to each other, the parallel to axis, the parallel to axis, so this will be again side. The sum of this 180, sum is the 90. Sorry. Now this is 90. This will be side. So we know these angles. This angle is equal to this angle is psi, Q S P psi and S P R psi, and this Q P T psi and P T X psi. Now from the geometry, uh, now we want to find the length of this. We want to find the length of PS. PS will be equal to PS upon base upon hypotenuse from triangle STP, uh, base upon PQ upon SP is equal to how much? Is equal to so this will be from triangle SQP. This is base. Perpendicular over hypotenuse is equal to sine of psi. This is equal to PQ is equal to FQP is equal to 2 rows sine of psi. Similarly, this is parallel to this from same triangle. This is equal to this. So, or you can find from this triangle. This is base, or from this triangle or this triangle. Now, PRP upon PS is equal to base. This is equal to cos of psi. So, this is equal to PR is equal to 2 row cos of psi. So, cos psi, we know that we know the rho is equal to how much? We know the formula. It is curvature 1 plus y1 plus equal to 1 and tan psi equal to y1, therefore y1, and again from the triangle we have derived in the this center curvature. If y1 is this, so we can sign this. Tan is tan slope. If you want to differentiate any point, it's slope, and this tan angle member the proportion is equal. So if you show Pm is difference by x, it's 1. So again we can find sine is equal to sine of psi is equal to y1 upon root of 1 plus y square and cos x. Substitute their values. PS 2 rho, sine plus substitute rho and sine psi here. We got P2. P2 and the chord parallel to chord of curvature parallel to x-axis. Similarly, we can find chord of curvature to the value of cos psi and rho.